And Michael Ayres, I'm the Managing Director of Flexible Power Systems, typically look after our strategic partnerships and some of our key customer relationships.
I'm Henry Clarke, I'm the Head of Platforms of Flexible Power Systems, and I look after the platform development and operation.
Did you start this together? You had an existing relationship before?
Yeah.
Before Power Systems?
So Henry and I have known each other for a long time. I guess sort of like 12, maybe or 15 years.
Michael hired me onto a PhD in a foreign business.
And even though Henry's much cleverer than me, I actually supervised his PhD, at least on paper, but which I never cease to remind him of. But we worked together at a business called Dearman for, I think, about sort of 5 or 6 years there, that Henry ran innovation. I was the Chief Operating Officer there. And then I started FPS in 2018, looking at the challenges of how you were going to integrate a sort of energy system that was changing very rapidly with a commercial vehicle sector that frankly was not ready for it yet. And I guess sort of a couple of years into that journey, the amount of innovation we were doing began to sort of get to a point where it was beyond what, with my limited skill set, that I'd be able to manage. And so I then sort of basically called up Henry to see if he'd like to do a bit of software development. And since then, you've been pretending to be a software engineer when you're secretly an aeronautical engineer.
Well, yes. I think originally when I joined FPS about 5 years ago, we were working on thermal batteries as well, which is more in line with my mechanical engineering background.
It's quite a bold move, like starting your own business in a industry that didn't really exist yet.
It really comes from my background. So the first company I worked for was a company called Highview Power Storage, and that they're dealing with the challenge of grid scale energy storage, and sort of absolutely massive scale. So sort of really interesting technology where you have to sort of be at 300 megawatts to sort of even be at the sort of right scale to do it. And so in that business, I learned an awful lot about the challenges of integrating the renewables into the grid, and the sort of requirement for flexibility. And then the second company that I worked at was a company called Dearman that was developing a sort of innovative new transport refrigeration unit technology. And working at Dearman and coming into contact with operators, I kind of realized that, well, if we're going to get to net zero, it's not just the transport refrigeration units we're going to need to do something about. It's the truck and it's the vans as well. And even then, the things which sort of make people skeptical about the sort of how realistic it is to use hydrogen, that was kind of obvious that, you know, that the sort of inefficiency of the energy chain, the sort of additional cost. And so it was very clear that a certain part of decarbonising transport was going to be reliant on integrating with the electricity grid. And just sort of seeing how nascent the sort of ideas about how electrification would even work in that sector, and knowing what I knew about the grid and how it was changing the renewables space, led me to think, well, there's going to be a few challenges here, and so that they're likely to generate sort of quite interesting business opportunities. And that's where sort of FPS came from. We spent the first sort of couple of years of our existence really exploring different versions of that. One of the first projects we did was trying to understand whether it was worth it to do V2G in fleets, and that actually that the answer then, probably now, is still probably not so much, because you need trucks to be on the road doing stuff. The caveat to that is obviously if you sort of pair them up with sort of different types of flexibility, so there's windows when you are in your depot will work, but the sort of value of it is not a kind of total game changer in those settings. And that's actually how we got into the sort of space of thermal batteries, so that we were doing a development project with Sainsbury's, and we were trying to sort of find ways to introduce flexibility into their power consumption so that they could free up headroom for EV charging, basically. And so that got us into looking at phase change materials in the context of refrigeration equipment. So whether we could sort of store heat, store cooling, which would enable us to sort of shape some of the electrical loads associated with heating and cooling store environments. And then it was the obvious question sort of following on from that was, well, maybe you could flex the EV charging loads as well. How do you do that? And then we sort of started off down this path of initially sort of seeking flexibility in terms of EV charging loads, and then diversified from that. I guess where the sort of Operate platform, which is our sort of core product, came from, is actually working with Waitrose, that they were putting their first electric vehicles into a store at sort of St Catherine's Dock over in East London. And actually it was sort of driven by their property team that had an interest in doing sort of sub-metering on sites and things like that. It was sort of like, is anyone going to get any data from these vehicles so we know what they're doing? You know, like we really need to know how much power is being used and when for charging, because then we can sort of plan what the load provision is across the stores and things like that.
It'd be helpful.
Yeah, and it was really the case that sort of like people hadn't quite necessarily thought of that anywhere in the supply chain. So that sort of Vauxhall was supplying the vehicles hadn't really sort of thought people would be interested in whether or not they've just got enough range to do the job. The people who were supplying the charge points were sort of like, well, obviously you want to see the sort of charging data if you were charging other people for it. And so there wasn't really a solution for Waitrose to sort of pull all of the information together about what the vehicles were doing, what the infrastructure was doing, and what the store itself was doing. Because really critical in that situation was we want to know how much our bill is going to go up because of the EVs, not just have the EV stuff and no context for sort of what's going on in the stores. And then that's where we started kind of connecting data together, wasn't it, Henry?
Yeah.
And I think most operators are almost coming to that same realization themselves as they progress on this journey. So, I mean, incredibly forward thinking of you to have made that realization almost before the industry made that realization and put yourself on a pathway that you can give them those solutions before they know that they need them. Yeah.
Yes. At times, I guess it's felt a little bit like what in the Yes Minister they call a very brave decision to be doing that at a time, because I think that there have been times in our journey where we've been talking to people and that they looked at us and thought, why the hell would I want to do that? Driving these vehicles around London, they don't run out of charge. Isn't that enough?
FPS was already looking at fleet operations for customers to help them understand the sort of electrification journey. So already looking at big chunks of data to try and get insights into how you might model that if you're planning it. So that to sort of collect this data and do something useful.
We first met through the Centre for Sustainable Road Freight, I believe, Cambridge University. What's been your involvement in?
We've had really good cooperation with them. So actually from the start of FPS, that we collaborated very closely with Phil Greening from Heriot Watt. So the first probably 4 or 5 development projects that we did with Innovate UK were in cooperation with Heriot Watt. And that was really fantastic for us because that we learned a lot that we didn't know about logistics and how sort of logistics operations work and what the real sort of drivers of cost in it. Because they're coming from a hardware background, as we did into this, that there's a sort of bias to think it's all about the vehicles or it's all about the chargers. Actually, what working with the Heriot Watt guys uncovered was that actually the supply chains are highly sophisticated. They're orchestrated by software that joins them end to end. And the reason that like every single asset in that supply chain is the size it is and looks like it does is to try and make that entire supply chain work as smoothly as possible. And so that it kind of gave us a bit of philosophy that we sort of took into sort of how we wanted to make our products work, basically. So by collaborating with Phil at Heriot Watt and his team, that we then started to contribute basically from the projects that we were doing with them, sort of research papers into the sort of Centre for Sustainable Road Freight, which then sort of brought us into contact with David Swan. We've done collaborative development projects with those guys as well. And I guess Jolt, which is another place where we sort of interact, is another project where we're working with those guys, where there's a real kind of alignment of interests. I think that as well as the research angle, another reason to work with them is because there's a real education gap in our sector that in terms of, particularly when we go to the sort of heavy duty end where that they tend to focus, that, you know, not every operator is aware that there's OEM product in the marketplace. Not every operator is aware that you could get a truck to drive more than 100 miles in a day, fully laden. And so the Jolt is kind of, I think, providing the data set, which can kind of help do some myth busting and things like that and sort of outreach. So we're kind of keen to support that. And the way that we support them is through acting effectively. I see it as a sort of like data caddy. You don't read to the sort of profs at Cambridge where it's our role in life to sort of collect together and aggregate all the data, is what the vehicles, the charge points are doing, and sort of serve it up so that the team at Cambridge can process it and provide insights to the sort of Jolt consortium members.
Yeah, I think transport is going through the same problem that a lot of industries maybe went through 10 years ago, which is this idea of digital transformation and currently siloed data sources. And before we can even think about decarbonize, a lot of operators are going to have to go through a digital transformation exercise. One of the key barriers is this idea of transport and energy colliding. And the things that sit in the middle of that are digital and so academia to a certain extent, and being able to deal with the complexity that arises in those two incredibly complex systems having to interact for the first time.
Yeah, it's also organisationally difficult. I mean, there may be entirely different teams within a large organisation that are not so used to working with each other as they have to be if they're deploying an EV fleet.
So what does flexible power systems look like today? What is the product?
It's a good question. Today, we're almost entirely a software business. So we make a range of software tools that fleets use to manage different aspects of their EV transition. So they may start their journey with us processing their existing historic data to understand what they can do in terms of electric vehicles and charging infrastructure. But then our offer kind of scales with them so that they may use our real-time management platforms to collect data from pilots and then use the optimization features of our platform in order to manage sort of electric vehicles and chargers whilst they're in service. In a nutshell, I guess, we sort of aggregate data and then find sort of useful things to do with it to sort of overcome roadblocks on the way to decarbonisation.
Data seems to be really at the heart of it. What does that data look like from transport operators? What different types of data are we talking about?
There's quite a range of data, so that there's, I guess, some of the biggest data, if you like, is coming from vehicle telematics, but just in terms of volume. So you might get a few million up to 5 million rows of data from a vehicle over the course of a year per vehicle. But then we also get data from chargers, obviously, and maybe about a tenth of that to tell us about the interaction of the chargers and the vehicles. The other data sources, the other big one really is logistics systems, so where we're interacting to pull information about the routes that the vehicles are going to take for the day and their progress along the routes as well. We also pull side meter data for managing power. So obviously you need to know about what the rest of the site is using if you want to know how much headroom you have available for charge optimization. And then other bits of sort of publicly available data for modeling. So, standard weather forecast type data, that will impact the model for site power consumption. And that we also pull data on public chargers, whether we're using that for the operators to help them work out where to charge on the road when they need to do that.
Telematics data absolutely fascinates me. We've got hundreds of data points coming off these vehicles now. How much of that is useful? How much is just noise? And are you seeing a huge disparity between sort of different manufacturers and different systems?
There's a lot of difference, especially equally in the heavy duty sectors and the sort of like by commercial vehicles. Some telematics will just provide you some of the raw basics. I mean, in fact, that as some of the OEMs sort of catch up with providing this telematics for electric vehicles, that we have had telematics data streams which don't even include state of charge, for example. When that's just they're sort of catching up and updating their sort of cloud telematics system. And there are some useful standards. It's much nicer when you're on board telematics streams which are sort of compliant with our FMS for heavy duty. That they're certainly not all like that.
Work to be done.
Work to be done, yeah.
I think we also see quite significant variations in sort of third-party telematics systems as well in terms of their reliability and also the sort of quality of the feeds. I think because things we've learned from handling telematics data for the last sort of 5 years have been that you can't just throw it straight onto the platform. That you'd be surprised how many telematics vendors in the marketplace throw telematics data straight onto their platform. So you log in, open up their Snazzy portal and find that there's a load of nonsense data on it. So there's quite extensive amount of cleaning and structuring which is required to make it actually useful. So you can sort of start to hope to drive insights from it.
Yes, there's very few which provide clean data.
You say very few. Does that mean there are some that provide clean data? Is there like a gold standard?
No, there isn't. I don't think there's a gold standard. I mean, for a lot of the telematics providers, that they measure the data and they provide it, and they don't make an effort to make sure it makes sense. That obviously, if the data stream goes out, then they'll fix that, but they're not trying to offer up clean data.
Do you find that the third-party solutions tend to be better than the OEMs, or there's something we've always struggled with? It's this idea that the OEMs, we've got mostly a Renault fleet, and they all have Renault Opti fleet, and they've all got SIM cards, so they're spitting out data. But we're not exclusively Renault, so if we want a single platform, then we generally need like a third-party telematics provider. But actually, when we're looking to the future of how we use data going forward and increasing that, our focus in that world, it's difficult as an operator to understand actually what's the best choice to make.
Well, I think that we sort of answer that with maybe, rather than trying to sort of install third-party boxes and things like that on your vehicles, is that looking at approaches where you can kind of aggregate those streams together is a way to do it. Because I think one of the things that we naively thought when we first started in this game was that sort of having a consistent box across all the different vehicles would somehow solve your sort of data consistency problem. But it's not really that, is it? It's sort of more what the vehicle's willing to give up to the box on the same CAN signal. So we've seen the sort of third-party telemetry systems, totally different things on the different vehicle OEM products. So for me, at least, and I guess I would say that's as a vendor of software that does this, is that actually using a provider like us to sort of aggregate all your telemetry data together and make it consistent, structured and clean in one place, then means you can operate this sort of mixed fleet and compare apples with apples, rather than sort of have the situation of like, I'll just look at optically and then I'll just sort of log into Volvo Connect over here. Let's go and see what's in PACCAR Connect this week. There's not a way to sort of like derive insights that you can sort of plan the rest of your EV transition from, is it really?
And actually, there's more than just the telemetry data that you need included in that. So these external data sources are really important as well, and combining those data.
We learned from that very first Waitrose project that to understand what's going on with the EVs, that no one data stream tells the whole story. And so if you can bring your telematics, your chargers, your building metering, your weather, your pricing information, logistics data all together in one place, then you can start to sort of drive insights from that data, which then means you can make better decisions when you plan the next stage of your EV transition.
It leads on to something that I've talked about a bit recently, which is this idea that the telematics providers sell themselves almost as software as a service. And I think as an industry, we might be moving away from that. And I don't necessarily need another platform, or I only need one platform. And what I want from telematics is the data, not the map and the dashboard and the reports and all that. And actually, I might want to own that dashboard, or have a provider like Flexible Power Systems that I'm working with. And they're the people that will give me that reporting.
Some of the OEM providers telematics are really good, actually. And one of the nice things about OEM telematics is that you get everything that's available on the vehicle, but you don't have to wait for a third-party telematics ST to be updated for new vehicles. So if there's information there which is provided in the vehicle, you'll get it.
So it feels like that is preferable. Is there an OEM that's better than the rest?
I think there's certain OEMs that have gone further with that proposition than others. So when we look at vans, I think that sort of the richness of what you can get out of the sort of Ford portals is probably better than what you might see from other OEMs. But I think that there's a growing recognition with all of them, I think, of the need to have this kind of digital component to their offer as well. I mean, what you're saying about the sort of third-party telematics vendors, that, yeah, I think that the days of let's show you some dots on the map of our vehicles is not where the value is. The fleets we work with are using some of the kind of the analytics features to sort of try and drive value. So I'm thinking about the classic use case of telematics is obviously sort of like driver behavior analytics, isn't it? And it's those driver behavior analytics that mean that there's an interest from sort of customers in having those portals, not just the data. Because actually knowing sort of the location of and heading of all of your vehicles and their ODA readings is not very useful in and of itself. It's like processing that data into analytics and then trying to derive some insights from it.
We do have some operators as well, though, who like to look at that real-time data, don't they, to be able to see what's happening with their fleet so they can support it.
Do they like to look at it because that's just how they've always operated? And we've mentioned insight a few times. I think that's probably the really important piece here. It's not necessarily about data. Data is providing the insight, isn't it? Where are we at on, I guess, surfacing insight versus having to ask the question?
Well, I think that in the journey that we've been on, the first thing was to basically get some data about what the vehicles and chargers are doing for an operator, because they just want to see it on one screen. And then quickly it transformed into, okay, well, can you just build us some analytics in that so we can sort of see trends, we can see outliers, they flag to us exceptions that Henry's talking about. We have sort of the alerts and things like that. But then actually we've been asked to sort of go beyond that into this kind of sort of intervention optimization space where it's kind of, I don't want to know that vehicle's not got enough range to do the next job. Actually, it's even better for me as a fleet manager if that instead of you just telling me that, you just assign another vehicle that does have enough range to go and do that job, and you get that other vehicle charged up so it could do another thing. That's even better. Because I think that what we've seen very clearly from the fleets that we work with is that people start off thinking that the EVs are a sort of special project and that we need like an EV person to look at it and things like that. But quickly the people want to get back to but actually I don't want any of my operational people to have a different job because that's an electric vehicle. So how can you take sort of those EV related decisions out of the hands of people who are sort of in the operational space? So sort of like the driver should not have to think, should I take that van out or should I take that van out based on its state of charge? Just tell me which van I should take out. The driver shouldn't necessarily have to plan where to charge their van. They've got enough to do. They don't want to be sort of screwing around with that map and trying to work out how many miles they get out of their van. The shift manager doesn't want to have to take those decisions. They've got enough to do with managing drivers and fulfillment. And so it's sort of supporting those decisions to make it so that everyone can just do their job as normal is more and more the exam question that we're getting asked for by the fleets we work with.
You touch on, I guess, automation and this idea of the tasks occurring without the intervention. How advanced are we getting with that?
In the first instance, optimizing your charge profile. So when your vehicles come back in the afternoon or the evening, they can be plugged in and they will charge when it's best for them to charge rather than necessarily immediately. And that might be because you're trying to manage power constraints and that 40 vehicles come back at 6 p.m. You don't want more plugged in at the same time, exceeding your site capacity. Or it might be because you get cheaper electricity overnight. So charging all your vehicles for 4 hours in an expensive period of the day is not the right thing to do when you're running your fleet. So just pulling in the price profiles for electricity at a site and monitoring the power and forecasting the power, so the headroom means that you can shift the charge to overnight or during the day between shifts to try and make sure that you minimize the cost. But if you know about which route each vehicle is going to take, and then you can model the energy that's required for that, then you know that a vehicle doesn't necessarily have to be charged to 100% before it starts a route. You can make sure it has the right amount of energy for its task, and that to do that, you need to be able to allocate the vehicles to the route. So allocating a vehicle to a route or to a task is the sort of obvious extension of that, which allows you to make sure that you've got more flexibility in your charging and to make sure that all your routes can be completed. Because the obvious part of the transition is that if you run out of charge in the day, it's not a 5-minute job to top up as it is with diesel. You have to kind of steer your vehicle on a charger for half an hour or an hour, or you have to find somewhere en route to charge it.
Are operators generally coming on board with this idea that they're going to have to trust a digital system to almost make these decisions for them? Are they leaning into, help me with this complexity, whereas traditionally a transport planner, for example, would want to fully control it, fully understand that, and sort of make those human decisions?
Well, actually, lots of these bits of automation are not things that would have existed with the diesel fleet. So that for lots of these fleets, that if you got the diesel vehicles, it doesn't really matter so much which one you take. If they're the same, obviously, if they have different capacity, then it does matter a bit. But then again, it's a sort of within a type. Whereas with the electric vehicles, you don't want to get in one with only 10% charge left of it. So that was less of a task with diesel vehicles. And again, if you do need to stop en route to charge, selecting where to stop was not an issue with diesel vehicles. That if you're stopping for a charge, you have to be a little bit more careful that you don't find yourself on a slow charger and losing 2 hours of your afternoon at the other charger you could put on your e-fuel card and it's not too far for you and so forth. And ideally one where there's enough charges you won't be waiting. So these are not really tasks that were being performed before. So then the way we approach it is that there is an option to override any of the allocations, any of the suggestions for charge stops. These sort of come in the form of recommendations that it's very possible for staff to change an allocation. They might have to do that if there's a vehicle which goes off-road, for example, or for a driver to choose a different charge stop. But there's nothing which holds them to the recommendation, so that the operators still have control. It's just that they don't by default have to do the job of making allocations or the charge stop.
Yeah, it's kind of like an assist to the transport planner, isn't it? In terms of dealing with all of the unfamiliar energy-related decision-making that sort of has now been introduced into their jobs. It's sort of having a platform that solves all of those problems, makes recommendations that they can then choose to build into their plans.
And how do you see that evolving as time goes on? Because in my mind, the algorithm will likely have more insight than the transport planners. Is there a sliding scale where you can start to insist that this is the correct decision, regardless of what the actual operator thinks? And there's a lot of grey area there, isn't there?
In the first instance, you can have more of the exceptions that might otherwise be picked up by a human. So I gave the example of a vehicle's off-road. So you have to switch it manually for a different vehicle for a route. That actually, for some of our customers, we already pull in data from their systems about which vehicles are off-road. So that we're already doing that in some cases already. And so it's not unless a vehicle's gone out of service on the morning that they will have to do that. So I think one of the directions of travel is just picking up more of those exceptions and handling them automatically, so that the fleet plan has to deal with fewer of them.
And I think that the other thing which is coming down the tracks is even more complexity, which has the potential to sort of overwhelm human planners. Because particularly when I look at the sort of heavy duty segment, that I can't see how we're going to charge those trucks without a great degree of cooperation and effectively sort of sharing of assets. And at the moment now, you can kind of facilitate sharing of charges. And I know that Welsh do this already, and with other operators, because there's like 5 trucks we're talking about here. But actually, when you start to get significant penetrations of sort of like 10, 20%, that actually the utilization on those charges is going to go up. And so actually that you need cooperation between operators about when they're going to use those charging assets, when they're going to call energy resources. And that type of cross-entity cooperation is quite hard for humans to do at sort of very large scale. And so that's when I think we will see the level of automation go up another layer, because that there'll be this kind of continuing negotiation between fleets effectively for sort of when they can access energy versus their sort of logistics plans, and trying to keep the logistics plans as optimal as possible whilst minimizing the fuel cost effectively. And so it'll be a sort of really interesting sort of set of problems to solve.
And we move from orchestrating an operator and some vehicles and some chargers to orchestrating a network or a system of logistics.
Yeah, and I think it will be a system. I think that there won't be one. I know that I've spoken to some technology developers who believe that there will be, one central sort of orchestration player that is going to schedule every truck in the country onto every single charger. And for me, I don't think it will be quite like that. I sort of imagine agents which are sort of negotiating with other agents of other operators, and they're sort of constantly sort of dynamic process. So it might be sort of let's say for sake of argument, that Welch's and John Lewis want to use the same charger, that you want to book it for the same time. Actually, there needs to be some negotiation between you. So maybe you guys booked it first. Perhaps that sort of John Lewis then willing to pay you a price for you to undo your booking and push it back 2 hours. And then, so someone needs to make a calculation of how that's going to affect your logistics plan, whether the price John Lewis are offering you is enough for you to unbook, which then means that the system can reorganize itself to get to that. Because I think that the road of having a central sort of orchestrator of all logistics and transport in the UK, I suspect, will be quite infeasible for many sort of separate corporate entities to accelerate it. So it will be, how do you keep that sort of dynamic negotiation alive? And we probably will need some kind of exchange type mechanism for that.
Yeah, I guess it's how do you lean into the level of intelligence that would be needed to orchestrate those systems versus market forces and this idea that we live in a democracy and everyone's got their own choices. And yeah, whilst maybe in some countries they try and, for example, might have that single, sort of one system to rule them all, it's not necessarily going to work in the Western world. And it kind of fits in quite nicely with how the industry operates at the moment, with the different pallet networks and the interaction between the tier ones and the tier two operators and how that all works.
Yeah, with quite a dynamic system. Even if you've got the most clever AI in the world, you can't make it work without being able to feed it the right data. So it needs to know what the jobs are that you're trying to do today. It needs to know what power prices you're going to be. Needs to know some stuff about the drivers, shift patterns, probably knows traffic conditions. Needs to know what the energy consumption is likely to be of your vehicles as they sort of work through their day. So it can understand the consequences of charging here rather than here. That you have to be able to feed that information in close to real time and have really great forecast models to make that sort of exchange type mechanism work, I think.
You said it before I did. AI. How does that change what you're doing? Does it change what you're doing? You move from, I guess, algorithms and processes to a different type of intelligence.
Yeah, well, I think it'll change everything you're doing, Quentin. That's it will certainly, I think, help power some of these sort of more complex negotiations. So the example would be able to book and do it between organisations that we're interested in using AI to sort of improve some of our optimization. That not really to make more optimal, but making it faster, making it bigger is really, really helpful. I guess the other thing is that there's an opportunity at the optimization of a site level to sort of go a level higher and facilitate power management across a number of sites, which are not all within the same organization if they're subject to the same local constraints on the power network. And so having AI sort of driven optimization, which allows you to account for the interests of the different agents within that sort of a system, I think will be quite interesting, especially as the sort of limitations of the power network become greater as the more fleets are electrified.
What sort of timescales do you think we're looking at?
Probably sort of next 5 years.
Yeah.
I would have thought that there'll be a significantly higher demand on the grid in 5 years. That's going to have impacts in essentially it'll be the pricing mechanism for energy, and that will be what drives this. That will be what gets sites to be really, really interested in how can I shift my power consumption to off-peak times? How can I collaborate with other sites to be able to take advantage of their spare capacity if they have it when we need it, or to sell my spare capacity when I don't need it?
I mean, there's a number of different developments that are happening concurrently that all interact and all almost have to work on similar timescales. And when we talk about energy, the deployment of energy, artificial intelligence, electrification, and how it interacts with, say, driver shortages and the rise of automation, driverless trucks, all that kind of stuff. And it all has to kind of happen at the same time and all on similar timelines. Otherwise, it will just go horribly, horribly wrong. Yeah.
Yeah, I think, though, that we don't need all these things to get out of the station and start doing electrification. I think we can get through the first sort of 30 or 40% of the fleet without any of this stuff. I think from an FPS perspective, where the AI stuff begins to come in is that when you have these dynamic multi-entity situations where the potential for faster solutions that are close to optimal becomes important to allow that type of negotiation. So sort of not, I'm going to use this charger or not, but can I flex my loads to sort of free up capacity for someone else, and how do I get remunerated? That's where we see it being useful. I mean, that we're starting that process now. That one of the things that we sort of won the first stage of the Manchester Prize for AI was using sort of reinforcement learning with agents to sort of solve these type of optimization problems, because we found that they can be faster than some of the sort of traditional methods. And one part of that is developing the algorithm, training the agents and things like that. The other part of that is trying to operationalize it. And so to sort of put it into sort of live environments, solving problems that we already know how to solve, but actually that it can be quite useful and effective of sort of understanding the sort of quality of the solution that you get and what you have to feed it, what can go wrong in terms of implementation. Because it's the implementation as well as these sort of like, cool things you can develop in a lab or on your laptop and things like that. It's like having put these things into real world live environments, and it's hugely valuable. And then it's that learning which prepares us for the sort of what we're going to do for the 70% balance that we want to get to, isn't it? In that world where we're trying to get autonomy, massive sort of energy network upgrades and dynamic flexibility, maybe sort of logistics, supply chain flexibility, greater cooperation, and we can see getting those teams to work. Multimodal stuff as well, I'd add into that mix.
I suppose the other place I think we'll be seeing AI providing additional value, extra value, in the shorter term is going to be, as with lots of other industries, in the sort of user interface side of it. So that at the moment we offer insights and analytics and data through our portal, through our dashboards. And so that you can go and have a look at, for example, how the changing temperatures is impacting different bits of your fleet. But the AI will mean that you can have some really snazzy interfaces where there's lots of pre-prescribed sets of things that you can look at. You can ask your AI assistant to give you a particular insight into, say, just the performance of vehicles in your fleet that have a transport refrigeration units on them, or how they perform at weekends, or whatever particular snapshot you want to see. It will be able to present that up to you from your database of historical data and give you insights. So on demand. I mean, that'll be a very cool thing.
It's basically sort of giving every customer the equivalent of sort of one of our sort of analyst team is willing to crunch numbers, or you are on hand all the time. They're taking steps in that direction, is sort of building agents for some UN projects actually to sort of help sort of disseminate knowledge about sort of electric vehicles. So you can ask sort of natural language questions to it about how to specify infrastructure and things like that, and it's linked into various kind of models and things like that. They can help people sort of crunch their own numbers. It's kind of an extension of that, isn't it? But sort of trying to do it in a way that produces sort of answers which are sort of relevant to operators, rather than just sort of like plot me this against that, which is sort of kind of where a lot of these solutions end up. It's quite challenging in terms of how you train the agent.
I think logistics is probably one of the most difficult industries to make all this stuff work, isn't it? Because it's so messy and human and physical.
Yeah, there's a lot of physical reality that goes with the sort of nice AI models and things like that. But then that's why there's this sort of real synergy between sort of having live, high quality data feeds and trying to do optimization and AI analytics and things like that. That it's kind of like all three things go together. I would say the logistics sector is a great place to do this in some respects because it's so data rich. Generally speaking, no vehicle moves in the logistics industry unless a computer system is told it to do so. And another computer system knows what's on that vehicle, so knows why it was moving, when it was moving. And so actually there's a very rich sort of stream of data that can be kind of combined together to sort of understand what has been happening in their system, and that there's connections you can make that can make those connections, can make that understanding very close to real time, and that can be enormously powerful for them predicting what's going to happen next.
I've often said that there's an opportunity for transport to almost skip a generation of technology. So whilst traditionally we've, maybe been 10 years behind other industries, and just now we're discovering dashboards and APIs, that actually a lot of us can just jump that whole piece and move straight into artificial intelligence and insight being given to you rather than having to ask for it in a way that a lot of other industries might struggle with, because they've already got these data lakes and these dashboards that they've spent years and years developing, and it's going to be harder for them to move away from it.
Yeah, and sort of in-house data teams and things like that to some extent may obsolete parts of their function to this sort of thing. I think there's certainly an opportunity for that, but I think that it's incumbent on solution providers like us to sort of really show the kind of killer use cases, because you will know better than us, Jamie, that particularly for the sort of smaller end of the industry, that everyone is always like, one poor decision away from oblivion, aren't they? And so that we need to demonstrate the value that this approach can take to operators through really sort of powerful use cases, so that people can understand how, when to apply it to sort of ensure they get the benefits and also critically kind of manage the risks of doing it.
I think it goes a stage further than that as well, and it's not just about showing value or return on investment, but there needs to be an insane amount of trust that that's going to turn out to be true.
Yeah, but I think that we've seen something of that with the way that sort of our deployments with customers have become increasingly automated. So having started from this base of show me the data, show me some analytics, or you could take that decision, that would progressively take more decisions for our customers. And I think it will be incremental. Like, I don't think that, we need some kind of AI overlord that runs every aspect of sort of transport operations. No. But the only down day one, actually, that if it can make a sort of transport planner's job sort of 5% easier by taking the things that tricky or time consuming or highly repetitive out of the way, that they can spend the rest of the time making better decisions on things that still require a human. And so I think there'll be a sort of degree of incrementalism in this that will help people to build up trust.
Or even just keeping as a transport planner's role the same whilst increasing the complexity around him.
Yeah, exactly.
Or be able to grow their business without adding more people into the team is something that is quite interesting. Do you think we'll get to the point anytime soon where we can just completely remove the humans and we can do it all without them? Or that's a dangerous thing to be looking at.
I guess we always find conversations with Phil Greening fascinating. Because I think sort of as an academic, he's usually at the sort of cutting edge of sort of what's going on with that. And when you talk to him about sort of, what people are looking at doing with artificial intelligence in terms of supply chain management, and then go visit the Robotarium and see sort of like what's possible in terms of like humanoid form robots now, and knowing what is already possible with sort of autonomous vehicles and things like that, you could absolutely see in, I think, 20 years' time, frame moving very large distances across multiple entities without ever being touched by a human.
Yeah, it very quickly gets to the point where the human is the weak point in the link. When you're dealing with huge data sources and incredibly complex operations, the different levels of communication, it very quickly becomes more than a person can handle.
Yeah, I think that's true.
Where do you think flexible power systems is heading next? Is it more as the same, but have you got ambitions to start controlling other things? Is it about building vertically or sort of spreading your wings? Everyone wants to be the monolith, don't they? Where do you see your place in systems?
I think for us in the short term that it's about spreading across different verticals. In fact, so quite heavily concentrated in logistics. Nearly all of our customers are sort of 3PLs, pallet network operators, retailers moving goods and services. We've begun to find that in other sectors that they've got the same kinds of problems operating electric vehicles, but they just look a bit different on the surface. So one of the areas that we're working with, which I'm quite excited about and quite interested, because the impact you could have, is the emergency services sector. So we've been doing development work in this space, looking at the problem of dispatching emergency service vehicles that are electric, because it looks pretty similar in terms of that you've got these highly skilled dispatchers who are taking decisions about type of police unit to send to an incident or what type of ambulance or fire appliance, and that they've suddenly got this new complexity that's been dropped on them to do with EVs. Of like, is the EV going to get there? how do I charge the EV up as quickly as possible to get it back into service so it keep helping people. And actually that kind of idea of being like a kind of an assistant to a sort of skilled operator is sort of quite close to sort of what we do. They need us to sort of aggregate data, they need us to clean that data up, they need to structure it, analyze it, provide prompts and support so that they can make those decisions. So that moving into that emergency services vertical is something that's coming next for us. Also, I think that there are opportunities around technician fees as well to do something better than what we have now. That is there a way to sort of more efficiently manage technicians' time so they can spend more time applying their technical skills rather than driving or charging? If there's opportunities to do that. So we're sort of quite interested in that space. I think that the other area that we're likely to expand into is this sort of multi-entity cross-supply chain space in the logistics sector. So one of the ideas that we had when we sort of first started the business was that where this is ultimately going is that sort of there's going to be a scarcity of energy, or at least power availability at sort of different times. And we operate these sort of highly connected supply chains that have a good degree of flexibility in them. Our entire supply chain is going to be able to sort of flex in response to sort of expected power and energy availability, which is a sort of much bigger data sharing and cooperation problem than the ones that we're currently solving at sort of individual entity level. So sort of working across these different entities to allow them to cooperate and operate low carbon assets across multiple sites, multiple businesses. I think that's where they will be going over the next sort of like 5 years as things scale, to make sure that we're sort of constantly at the bleeding edge of sort of like what's being done so that everyone is confused when we tell them what we do for a living. Yeah, the people are beginning to understand it, like to consolidate some data across different streams. But
yeah, it goes back to something I often say, which is like everything is logistics, really, from event management to manufacturing to, like you say, emergency services, and it's all just logistics at the end of the day. And anything that moves and needs someone to tell it to move or where to move, is basically a very similar system, isn't it?
Yes, exactly. But I think it's a general feature of decarbonisation that actually that we're entering a world where there is maybe sort of less flexibility in terms of generation. We've got more sort of distributed assets, and having active management of those assets in ways that are sort of very rapid in terms of the ability to sort of reorganize and reoptimize is going to be hugely important to making that whole system work. Sort of beyond logistics and transport, thinking about the wider energy system, production processes and things like that. But the exciting thing for me is that we actually have a lot of the tools required to make that happen. That it's kind of almost a use case that sort of IoT and AI that's being put into businesses over the last sort of couple of decades has been waiting for, I think. And so sort of being able to join it all together is actually hugely exciting.
You recently won a motor transport award.
Yeah, we did.
What was that for exactly? Sorry.
Thanks, James. It was the best use of technology.
And they're the Oscars of road transport. That must be incredibly validating, and actually it's quite a kind of line in the sand for where this industry is heading, I think.
Yeah, we were highly delighted to win a motor transport award that we'd recognise with you, that they're sort of pretty prestigious. That what we won that award for actually was a sort of subset of our software product, something called a TRU fuel saver. So it was about, there's many people who operate temperature control fleets. We're aware it's quite a good idea to plug them in when they're in distribution center environments, because you can save a substantial amount on fuel. But people don't always plug in for a whole variety of reasons around sort of proving the business case, drivers not being bought into the program, power constraints that mean you can't actually use the infrastructure. Sometimes plugs don't work when you get there. And so we basically built a digital platform that monitors plugs in the distribution center environment, much the same way you might monitor an EV charging network. And it basically enabled Waitrose, who were the first customer to try this, to overcome all of those problems around driver acceptance, power availability, proving that the fuel savings could pay for the infrastructure to their finance department, And so it supported their transport refrigeration unit plug-in rollout program.
Is there a piece of data or at least some information that you wish you had when you start to operators and when you start to build these systems that you think, oh, yeah, if only we monitored that more closely, that would be really, really helpful?
I would like us to be able to access better battery health data. And it's coming because the EU legislation means that quite soon it will be a requirement for OEMs to report battery state of health.
It's in the new RFMS standard, isn't it? Along with some power takeoff stuff.
Yeah, and for like commercial vehicles that the UK or I guess GT22, when they adopt that in line, but it will mean that there's sort of some additional data, which I think will probably be quite helpful for sort of second-hand market in EVs as well. And it will allow people to sort of understand a little bit better what's happening with their fleet as they go through the transition, because I think the worry has been alleviated over the last 5 years of electrification of vehicles in general, that batteries are going to last 15 minutes before that you've got half of your asset price, which is no longer worth anything. And they're pretty good, but it's quite hard to get sort of solid data on how good at the moment.
Yeah, it's mostly anecdotal. Yeah, we know that they're doing better than what we thought they would, but until we are running these vehicles for 10, 12, 15 years, whatever that looks like, it's quite difficult to really quantify, isn't it?
Yeah, exactly. And for things like the optimization that we do, it'd be really nice to be able to put a value on, okay, so you know that ideally you keep your vehicles at 50% state of charge if you want to maximize battery health. Clearly, you're not going to do that if you need to use them the next day and you need to do longer routes. But knowing the value of trying to change your target state of charge, whether you have flexibility to do so, would be interesting and could drive optimization.
Yeah, well, I guess we have the capabilities to optimize. We need to know what we're optimizing for, don't we?
Yeah, exactly.
Yeah, that's fascinating. Thank you. That's been incredible.
A pleasure.
Thank you.